we are seeing similar design patterns. The design patterns which look similar but they are different. And in that series, we have a decorator design and we have visitor design. So both are different, both why they are similar. Decorator design pattern means there are two things generally. Now in Python era, everything is attribute. Like if we have a user-defined function also in the class, then that is also an attribute. So the only difference between integer as an attribute of a class or class object and any user-defined function is one has called underscore that is a special attribute it has, so it is callable. Otherwise, all are attributes. So that is the concept now it is coming. But anyway, in the class, we have kind of two kind of things in a class. So we have attributes and we have methods. So like in C++ kind of a static, in Python kind of program, uh, we can have attributes added at runtime. So we can add attributes at runtime. So that is the concept in Python. So many design patterns are kind of implicit in Python. So design pattern they generally they enjoy on polymorphism. So that is something that it provides. So Python is inbuilt polymorph. Everything is object pointed, and anyone can override any. So that is the case. But anyway, traditionally, if we talk about design patterns like visitor design pattern and decorator design pattern, then decorator design pattern adds attributes. If we need addition of attribute in a kind of like if I have a there are few classes that we cannot like built-in classes we cannot enhance it. We have to derive from it, and then we can enhance it. We can means we can extend it. So still means there are classes that we cannot make it kind of amendment. So in those cases, if we need to add attributes, then we use a decorated design pattern. And if we need to add behavior, okay, one means behavior in the sense that methods. So method generally it comes in behavioral design pattern because it is more versatile. So visitor comes under behavioral design pattern because we are adding methods or behaviors at runtime. And decorated design pattern comes under structural design pattern because we are adding attributes at runtime. So these attributes concept forms in a structure of a class. So this comes under a structural design. So a decorated design. So how we can add attributes to a class without kind of changing a class. So if I have a class, decorated design pattern is heavily used in Python also, where we can we can declare a decorator in front of function or class, and then it becomes the function. If I have a decorator, it starts with ampersand. So if I have a decorator before a function, then function becomes decorative, and anyway we have the decorator. So how kind of a decorator concept comes into the picture? Like I have a printer, and if I say I have a printer, I don't know which printer. Means it has a function called print, and I pass a page. Okay, so printer. Then in my call means I have algorithms written, and at the end, so like I have a printer pointer. Printer pointer I received through a function parameter. So in the printer pointer, I just say print. I pass the page and it prints the data, whatever the data kind of I can say print page and the data, and it prints it. Printer can be any type. I don't bother because it gives the it implements one with interface, and it gives a method called print. So I don't care. So it prints. Now, with the same printer, I want border also. So when it is printing something along the border, either it can be a thick line or my company name whatsoever. Now in the algorithm it's not available. So printer algorithm takes the page, takes the data, and it prints in middle, in the center. Now if I want border, it's not possible. Means it's become a chaos condition, chaotic condition. That I receive a printer pointer, and if I say print, then it would not print the border. What I can do? So this is decorated design. So idea is that the printer realizes an interface. So interface name is I. So from I, printer realizes. If it is not realizing interface, we'll make it. So in the design, we have an interface. From the interface, the printer class realizes it. From the interface, we have decorators. So both are, from the interface we have printer. From the interface we have decorators. Decorators are also classes. Now printer realizes or implements interface. Decorators they also implements interface. If they implement same interface, means with the same interface pointers, we can call functions. If there is a print function in the interface, then against all the subclasses, we can call print. Okay, so this is decorated design. So I have an interface. From the interface, I have the concrete class that derives from the interface, implements the interface, realizes the interface, and it has a method, any method like do it or print. From the same interface, I derive decorator classes and provide same methods like print or do it. What's it? Now, when I pass the function which is doing all the job at the end, it says printer print, so it receives a printer pointer. So now with the design, it would receive interface pointer. So from the interface pointer, or it was anyway, if it was receiving something abstract, it is fine. Now with the new design, now it will receive interface pointer and it is permanent. Now through the interface pointer, I can say I print. Now interface pointer, if I pass printer, a concrete class itself, then it will print the way it was printing. So this is a function, algorithm function. From the function, there is a parameter. That parameter is interface pointer. Inside the algorithm, we are doing manipulation on the data. At the end of the function, I am saying I print. So interface pointer, I am calling a print. If I am calling a print, then it will print the data on the page. Now, if I the interface pointer, if I pass the actual printer as a concrete object, then it would print on the through the concrete object print function. So the on the page data is printed. Now how we structure? That's why the structural design part. So I have a class which is kind of I can say as a border print. Border printer is a new class that derives from interface. Printer already has a class that derived from the interface. Now border printer contains printer. Okay. So border printer and printer they both derive from same interface I. Border printer when I instantiate in the constructor itself I can pass the printer object. Okay. Anyway, it takes I pointer only. So border printer in the constructor it takes I pointer, and in the object I pass the printer. I mean border printer contains the printer. Now, when I have algorithm function in the interface pointer, I pass the border printer object. Since our algorithm will never change, at the end it calls I print, but I is border print. Now border printer takes the page and very nicely it prints the border. Once it is done, that page is passed nicely because it has the printer object inside, contains it. So then it passes, or we can say composes it. It passes it to the printer, and Mr. Printer does its job. At the end, whatever the output what we receive is a page where data is printed and along a border is printed. Now I want one kind of logo on top right. I have a logo printer. Now logo printer derives from interface, and I have a kind of border printer derives from interface, and I have printer derives from interface. So this is a core architecture. We can have kind of hierarchical architecture also. So from interface, our printer is derived. From interface, we'll have decorator derived. From decorator, we can have border printer and logo printer like that. Or from border printer itself, I can derive logo printer if you feel that it's a part of a border. So this kind of hierarchy there, at the end it is I pointer, interface pointer. So this way, so when whatever the object, the concrete class, whatever concrete class is doing, if you want enhance functionality, so whatever, suppose like in Python, if I have a function called func, but I want a kind of more functionality than func provides, then we have a layer of decorators on top of it. So first decorator would call contains second decorator. Second decorator contains third decorator. Third decorator contains the function. Now the Python interpreter returns the topmost decorator as the return. So our function is way inside it. So whenever in our code I call my function, actually decorator gets called. Now decorator they do their job, then call second decorator, they do their job, then call third decorator. They do their job, they finally they call the actual function, but it is not in our hand. And then the result is returned. So decorator is used when we want more functionality, more attributes with the same interface what we were using earlier. So if I have a function already written, and if I want enhanced functionality inside the function, no need to write function again. We can have a kind of decorators. Decorators comes into the picture up front, and they keep containing the other decorative at the end function comes into the picture. So whatever returned from all the game is the topmost decorator. Like that, in C++ and those areas also, the topmost decorator they contain the other decorators. At the end, we have the object. So we consider in this fashion, like if I have a logo printer and then border printer and then printer, means printer, our old printer has now new attributes called border drawing and logo drawing this way. So if I want to make a printer grow in its attributes without changing the algorithm where we are calling the printer, and then without changing the printer class itself, then we can go with the decorators. And the schematic diagram, class diagram, inheritance diagram of decorator would be that the actual concrete class would derive from an interface, then from the interface, all the decorators would derive, and then obviously they will implement those abstract functions, virtual functions, and through those functions, slowly we'll reach the actual concrete class. So this is decorated design. Amazing. Okay. So this comes under a structural design pattern. Can we think in real life how it can be decorator design pattern, where the decorators, the new decorators and the concrete class that is the decorative and decorators all follow same interface, and we start with the decorators and the wrapper is getting unwrapped one by one, and then we feel that then finally we come to decorating. So okay, so in war kind of situation, so there was a warrior, Changiz Khan, okay, a Mongolian warrior, Changiz Khan. I believe the only warrior who never lost any war, Genghis Khan. So, what was the kind of the speciality? I mean, I'll give example of the Genghis Khan in visitor design pattern also. So, in the decorator design pattern, so what is the main kind of the the principle? What was the main charm of the army of the Genghis Khan? Genghis Khan himself was a big warrior, but the structure of the army, what he used to make, that was exemplary. At the runtime, when war is going on, if something harm is happening in the army, then that would be replaced immediately. This gives the concept of interface, one thing. Second thing is, you can add a cavalry. Like in the war, you feel that you should add camel revenue. I mean, cavalry. Okay, so you have a horse cavalry. Anyway, you have elephant marching, you have soldiers marching, and then you have a soldier with kind of horse cavalry. Now, at runtime, when war is going on, and then suddenly you feel that on this kind of land, camel cavalry would be very fit, but we cannot add, right? Because camel cavalry, they have their own rule and regulation. Suddenly they cannot come and they start fighting the way you are. They don't know. They don't know. If they follow same interface, the way horse cavalry or marching elephant or marching warriors or the warriors who are with bow and arrow, if they follow same interfaces, you can fit in at runtime. This is a structural design fact. Means since camel cavalry also follow the same design, same kind of interface with the same method, they can fit in at runtime. Now your army structure is growing. Your attribute of the army has attribute, or the warriors has attribute as marching warriors, marching elephants, horse cavalry. Now one more attribute came as camel cavalry. So nice. It was there. This is how Genghis Khan was invincible. No one could defeat Genghis because of the design patterns he used and the way things he would replace, bring it new, take it away, and nothing would have changed. Means all the soldiers they would feel the same because everything went through interfaces, and then he always won. So that is a decorator design pattern. Now we'll see visitor design pattern.